Hello friends, welcome to engineering tutorial. So we'll continue our discussion on projectile motion. So in the previous videos we discussed some of the theoretical concepts and formulas associated with motion in a plane and a very important case of two-dimensional motion or motion in a plane, which is projectile motion. So in the next series of videos we'll be discussing some questions on projectile motion. So related to motion in a plane, we have discussed a lot of questions in the basic physics playlist which are related to vectors. So you can check that playlist for questions on vectors, okay, vectors in a plane. So next series of videos will be on projectile motion, some important questions, some problems. So this is the first question. It is given that an object is thrown horizontally with a velocity of 10 meter per second from the top of a 20 meter high building. How far away from the base of the building does the object strike the ground? Okay. So let us first draw the diagram. So we have a 20 meter high building. Okay, this, let's say, is the building. This is the base of the building and this is the ground. Forgive my drawing skills, they're not that good, but still I will try to manage. Okay, this is 20 meter, the height of the building. So a boy standing on the top of the building throws a stone with a horizontal velocity of 10 meter per second. So again I will divide this whole discussion into two parts: projectile motion with horizontal projection and projectile motion with angular projection, so that there is clarity. So the first set of questions, series of questions, will be on horizontal projection, then we'll go to angular projection. So this is horizontal projection again, as you can see, horizontal component only. Now here we have to assign some parameters. Again, the equations of motion will come into play, the basic equation of motion. As we have discussed, in one-dimensional motion, they are written as V is equal to U plus AT, S is equal to UT plus half AT square, and then we have V square minus U square is equal to 2AS. Here U stands for initial velocity, V stands for final velocity, A for acceleration, S for displacement, the net change in position, and T is the time instant from the point where the observation starts. Again, when we discussed two-dimensional motion, I told you that these three equations, they are suitable for one-dimensional motion because motion is happening only along a straight line in one direction. So there is no need to resolve the thing into components. But in two-dimensional motion or motion in a plane, motion happens along two directions. Two position coordinates, they change, whether it can be x and y, y and z, or x and z. Any pair of coordinates, it changes. So here we have to split it into two parts. We have to analyze the motion separately, which is called as the principle of independence of motions, vertical and horizontal. So we'll split it into two parts. Here this equation will come into play. Okay, this equation. So we'll write it into two parts. First, Sx is equal to uxt plus 1/2 axt square, and then Sy is equal to uit plus 1/2 ayt square. So here Sx is the net displacement of the object in the horizontal direction or x-axis. Sy is the net displacement or net change in position along the vertical direction or y-axis. Ux is the component of initial velocity along the horizontal direction or x-axis. Uy is the component of initial velocity along the y-axis, the vertical direction. Ax is the acceleration component along the horizontal axis. Ay is the acceleration component along the vertical axis, x and y axis. So here if you see, the projection is horizontal, okay, and there is no component of velocity along the y-axis. So simply we can say that this 10 meter per second is ux and uy is equal to 0 meter per second. Okay, then when the stone is thrown with horizontal projection, the trajectory is something like this. Okay, finally the stone reaches this position and it strikes the ground here. Here the net vertical displacement of the stone, is simply the height of the building, from the top of the building to the base of the building, point which is on the same plane as the base of the building. So the net vertical displacement is simply the height of the building. So this is equal to Sy. Okay, Sy is equal to the height of the building, which is 20 meter. Displacement along the vertical axis or y-axis. Next, which is being asked in the question, how far away from the base of the building does the object strike the ground? So this is the point of impact, this point, okay, the stone strikes the ground here. This is the base of the building, and this is the point of impact, the impact point. So this distance, which we can call the horizontal distance or range, this is the net horizontal distance covered. So this is equal to the net change in position or net displacement along the horizontal direction, which is Sx. Okay, this is done. Then acceleration due to gravity g is acting downwards. Okay, it is only acting downwards, there is no horizontal component. So here, for the downward motion of the object, again for the stone, the object which is thrown, whatever it is, stone or whatever it is, the object which is thrown, it has two motions. First, guided by the horizontal velocity, and then by the acceleration due to gravity in the downward direction. So we have studied in the motion in a plane that this stone, for the downward motion or the vertical motion, initial velocity is 0, so only acceleration due to gravity is propelling it in the downward direction. So acceleration due to gravity is in the same direction as the motion of the stone, the vertical motion of the stone. So Ay is equal to g plus g, okay, plus g. So here, as nothing is mentioned, so we can put the value of 9.8 meter per second square, and there is no acceleration component along the horizontal direction or x-axis. So Ax is equal to 0 meter per second square. So now we have all the values assigned, we have all the parameters. Now simply we have to put the values and get the answer. So first, Sy is equal to uyt plus 1/2 ayt square. We'll use this equation. Sy is 20, okay, is equal to uy, which is equal to 0. So 0 into t. So this will become 0 plus 1/2 ay, which is equal to plus g, which is equal to plus 9.8 into 9.8 meter per second square into t square. This. So that implies So that implies 1/2 into 9.8 into t square, that is equal to 20. That implies t is equal to 2 into 20 by 9.8 root over. So it is coming, the value, let's calculate, it's coming, it will come close to 2.02 second, this much. Now this time which we calculated here, it is nothing but the time of flight of the object, the duration for which it was in the air from the time instant it was thrown until it hits the ground. You could have, if you remember the formula of time of flight for horizontal projection, time of flight is equal to root over of 2h by g, where h is the height from which it is thrown, g is acceleration due to gravity, and the remaining is same thing which we have done here using the equation format. Okay, 2h by g, height of the building 20 meter by g, same thing. You could have calculated directly also, but to make you understand how it is coming, I have shown you both ways. This is the first way using equation format, and this is direct formula also. You can arrive at the same result. So time of flight is equal to 2.02 second. We have calculated that. Next we'll come to this. So Sx, which is the horizontal range or horizontal distance covered from the base of the building until the point or the point where the stone hits the ground, that is simply the horizontal velocity multiplied with the time of flight. So that is equal to 10 meter per second into 2.02 second. So that is equal to how much? 20.2 meter. So this is the answer which was asked in the question. Okay, how far away from the base of the building will the object strike the ground? This, and that is equal to 20.02 meter or 20.2 meter, sorry, 20.2 meter. Okay, this is the answer. This is 20.2 meter. This. Okay, so here both approaches are there. If you remember the formula, then you can directly put the values and get the answer directly. Otherwise, if you for some reason you are not able to recall the formula, then always use this approach, the equation approach. Okay, if your concepts are clear and you forget the formula, still you can get the result. So both approaches are there for you. Whichever way you are comfortable, you can go forward. Okay, so this is the first question.